Alright, this is the introduction for the series and parallel lab, and what we're going to do is you're going to pop open this simulation just right here, and we're going to just mess around with it a little bit. We're going to stack together some batteries, and kind of what you would expect is as you stack batteries together, then you can increase the voltage. Then what you're going to do is you're just going to build a very simple circuit with just a battery and a light bulb, and you're essentially going to prove Ohm's law. So what this is going to look like is you're going to pop open the simulation. It's going to have a home screen that looks like this. I personally just use the intro. The lab is useful, but not too useful. And you're just going to make something like this, and you're going to mess around with the battery voltage. To do that, if you just left click on the battery, then you can mess around with the voltage using the slider. If for some reason you wanted to measure the voltage, then you can measure the voltage just as such. And if you wanted to measure the current, then you're just going to drag this thing over and measure the current as such. Something to note is there's only one quote-unquote pipe the current to flow through, so the current on the left is the same as the current on the right. That's going to be kind of important. Then we're going to build some series circuits and some parallel circuits. You're going to build three of each. The first one is going to have just one battery, or one light bulb. The second one is going to have two light bulbs, and the third one is going to have three light bulbs. You're going to measure the current here and here. You're going to measure the current here, here, and here, and then you're going to measure the current here, 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 and here. You're going to measure the voltage across the battery, the current going into the battery, the current into bulb 1, into bulb 2, into bulb 3, and the voltage across bulb 1, bulb 2, and bulb 3. You're also going to make a note of the brightness of the bulbs. So what this is going to look like is I'm going to pop open my simulation, and what we can do is we can measure the voltage just right here, and then we can measure the voltage right here, and we can measure the voltage just right here. Now something I will note is it is negative. If I wanted to fix that, then all I have to do is I have to swap these guys around. So if I wanted to measure the current, pretty straightforward. I can measure the current right here. I can measure the current right here, right here, right here, and just right here. Not surprisingly, the current is the same in all these locations because there's only one quote-unquote pipe for the charge to flow through. What we're then going to do is we're going to do the same exact thing, only we're going to do it for parallel circuits, and we're going to measure the voltage and the current across the light bulbs. I've mocked up the most complicated one for you. Something to kind of note is when you're doing this in the real lab setting, it's a whole lot messier than it is right here. So what we can do is we can go ahead and measure the voltage just right here, measure the voltage right here, and this is a parallel setup, so the voltage ought to be the same. If it's not the same, then we got some big problems going on. So I've measured the voltage on those guys, and now we want to measure the current. Remember that current is going to be conserved, so we darn well better find out that the current from this plus the current from this plus the current from this adds up to the current flowing through the battery.